Well, here we are at the last part of Chapter 3. This is what we did in our last segment, where we took any normal distribution and we could find out what proportion, or remember we could use the word area or probability. So in this particular example, we'd say what proportion of men have heights less than 68 inches. And then we could find that out. We'd have to standardize 68, and that standardizes using that Z equation. So the standardized score would be Z equal 68 minus 70 divided by the standard deviations for this particular distribution, which was 2.8 inches. And then we find out that the standardized score was negative 0.71, and we used our standard normal tables to find that area. Now we're going to look at a slightly different problem. Now what we're going to say is, what height, we want to find the height such that 10% of men have that height or less than that height. So another way to say that is, how tall must a man be to place in the lower 10% for a man in that age range, 18 to 24? So what's going to happen here is it's kind of reverse of what we did. We're going to have to look in the body of our table to find the closest Z-score we can to it. So what we're going to do is we're going to pull up our Z-score and we're going to try to look for 0.1000. Now looking at this chart, I don't see 1.0000, but I do see a number, so we look for a number a little bit more than it and a little bit less. So I see 0.1003, and then I see 0.0985. That's a number just smaller than and just larger than. So 0.1000 would be in between those two. So how we work this, since we don't have it exact, we just find the number closest to the one that we're looking for. Now I like to take the decimal points away and just think of these as regular numbers. So I think of like 1,003 is only 3 away from 1,000, and that 985 is 15 away from 1,000. So that's very easy to see that 3 is closer. So I'm going to use negative 1.28 as my Z value. Then I've now found the standardized score such that 10% is below. So there's my standardized value. Now I've got to take a standardized number and turn it back into a value in the distribution. And this is how we do that. Now taking a look at this slide, we know how to standardize a number. We say Z equal X minus mu over sigma. Well, if you do just a little bit of algebraic manipulation, not that you ever have to do it, you can just believe that the equation is true on the right, you would just solve for X. So you'd multiply both sides times sigma and add mu to both sides. So we find out that the unstandardized score we can find by X equal the mean of the distribution plus the product of the standardized score times the standard deviation. So how would we do that for our example? We would use our formula to find, we know that the mean is 70 and a standard deviation is 2.8. So to find that value, to unstandardize that negative 1.28, we would just put it into our formula and find out that a man that is 66.42 inches tall or less will place in the lower 10% of the population. So let's take another look at an example. We're in the same distribution where the mean is 70 and the standard deviation is 2.8. How tall must a man be to be in the lower 5% for men aged 18 to 24? So what that means is we're looking for the standardized score that goes with 0.05, 5%. Well, when we go to our chart and we try to look up 0.0500, we don't find it. We do, however, find the probability of, or area, or proportion of 0.0505, and the Z-score that goes with that is negative 1.64, and we find a probability proportion or area 0.0495, so just a little bit above and a little bit below. So the little bit above was the 0.0505. The Z-score that went with that again was negative 1.64. And then the one just below, 0.0495, the Z-score with that was negative 1.65. But what do I do here? They both are equal distance away from point 0.0500. Generally what we do for this is we take the average of the two z-scores, and we're going to get negative 1.645. And so that's our standardized score. And now we're going to have to take that standardized score and turn it into an unstandardized score so we know that height. So we're going to take that z-value, negative 1.645, and unstandardize it. And again, remember the formula. So a man would have to be approximately 65.39 inches tall or less to place in the lower 5% of all men in that population. And I can now do the same exact thing to find the upper 5% in this distribution. In other words, a man would have to be approximately 74.61 inches to place in the upper 10%, because when we already know for the lower half, our z-score was negative 1.645. So if I'm looking in the upper half of the distribution, the z-score is just going to be the symmetric pair to that, so it's going to be positive 1.645, and I unstandardized that number, and that's where I got the 74.61. Now let's take another example, and I'm going to ask you to find the quartiles for this distribution. And what exactly does that mean? So let's look at this distribution where the mean is 2 and the standard deviation is 3. What do we mean by quartiles? Well, quartiles break things up into quarters. So you'll have a lower 25%, and of course you know the second quartile is 50, so that would be the 50 percentile, then the 75 percentile. So I can find the quartiles for this distribution. So the first thing I have to do is I have to find the standardized numbers. So I'm going to look for my first quartile. The standardized number that goes with that is the number such that 25% of the area, the proportion, or probability is less than that z number. So I'm going to go to my chart. So if I'm looking at the chart, I don't see 0.2500. I see 0.2514, which goes with the z-score of negative 0.67, and I see 0.2483. The corresponding z number with that, or z-score, or standardized number, is negative 0.68. So now I have to determine which one am I going to use. Well, 0.2514 is basically 14 away, and 0.2483 is basically 17. Remember, I take away the decimals and just pretend that they're numbers. So the closer number is the 0.2514. So I'm going to go with the standardized score of negative 0.67. And now, in this specific distribution, I can tell you where the 25th percentile is by unstandardizing negative 0.67. So, again, once I found the z-scores, all I did was I changed the z-score at the first quartile, which was negative 0.67, and I standardized that number using the formula, and I got negative 0.01. Then for the second quartile, which is the median, well, the median, mode, and mean are all the same in a normal distribution, so my second quartile is just 2. Now my third quartile, I know due to the symmetry of a normal distribution, if the first quartile is negative 0.67, then the third quartile is going to have a standardized number of 0.67. So I use my formula, 2 plus the product of 0.67 times 3, to get my third quartile. Therefore, I found my quartiles. So hopefully this will help you to solve some of the problems in your homework and to work some of these normal distributions. It's very important for you. So this concludes Chapter 3.